Hi, so it's been a little bit of an interesting last couple hours. I've been picking people's brains on how I've implemented my map system that we've been working on the last couple episodes, and I of course had to fix my workspace. It seems to be a continuous problem. The solution ended up being reinstalling IntelliJ, which tells me there was a problem there, but it disappeared in the process of uninstalling and reinstalling. Still a bit concerned of what exactly happened, and I haven't really explored too much of the new version of IntelliJ because I did end up updating a couple versions forward. So let's pray nothing else breaks. So far, it looks like there's been some coloration changes. They've changed the look of the folders, which I'm not sure if I approve or disapprove of. It actually is a little easier on my eyes, but having that bright colored folder was kind of nice to be able to quickly discern things, but the more similar color scheme is a little easier on my eyes, of course. Same thing, they've done a few things here where the filled properties have kind of changed or something. I'm not sure what's exactly going on here. Okay, so yeah, the gray, which is right here, is actually telling me the name of this method's parameter. Okay, so that's cool. Anyways, we're gonna get back into this. My workspace does work, so we can actually sit here and test things. We're still not quite to the point where we can implement the metadata change, and I need to do a lot more testing, but uh, we'll work on it. Also, when it comes to yesterday, I did make two more videos, but both of them ended up being really poor quality, so I only uploaded one of them. Apologies if what I'm working towards doesn't quite make sense and you don't really follow, because of course those two videos were never uploaded. Main reason, of course, is a lot of background noise, a lot of interruptions. I was getting continuously interrupted while doing things. You've noticed from a couple of my videos there's been some gaps in the interruption there. But anyways, let's go ahead and fire one of these nukes off. And let me kill my speakers here. I was on speakers listening to Pandora while trying to fix my workspace. Things are still going pretty good. We got some block updates here. Oh, radiation blindness just hit me. I still need to work on that. I'm gonna probably opt the creative mode player out of it, of course. As you noticed from previous couple videos, I've changed the color of the scheme of the color stone. We're gonna work on this a lot more. This is one of the things that the extended metadata is going to be used for. Sorta, as I've noted, the extended metadata is more than likely going to be used just for the actual texture. So you'll switch between this texture and that texture and cobblestone, and then we'll use the heated map to store the temperature value. I still haven't quite figured it out. I'm looking around at different possibilities, and this is the reason I've been talking to quite a few people, is I haven't figured out exactly how we're going to do that. I know for a fact I want to do it, but then I'm running into concerns about memory management. After all, we are talking about a game that already has problems with memory. Um, Anyways, let's go ahead and close this down, and let's dive back into working on the mod manager here. Or not the mod manager, the extra data manager. And we might do some other stuff here. Well, actually, probably not today. I still got to do other stuff myself here, but I don't have to necessarily record it. I've got a couple mods to work on and a lot of bug fixing to work my way through and a lot of API changes that need to be done. But let's go down into the core here. And we want to go to our world maps. We want to go to block data, and we want to finish up these two classes here so we can start implementing things. The number one implementation we want to kind of really work on is just getting something we can prototype in game. We are going to use the heated block for this, but I think we should be well within doing things here. So we already have a get map for dimension. We already have load checks. I am working on the save system. This is something I did in those other two videos. I was starting to test the save system if we actually work our way down into our test cases. And we find, here we go, map. We do have some tests starting for here. I was starting to work on chunk save and load tests. This is something I'm going to work on myself. The prototype we're going to build up probably today will not have any saving, unfortunately, because I have to figure out how I'm going to save the chunks. Right now, I'm going to more than likely save them individually, but I'm looking at the possibility of trying to mass save, and I got to figure out which is faster, which is better on the hard drive. And right now, individual doesn't seem to be too big of an issue, because what it'll do is it'll create a whole bunch of index values inside your hard drive, which is not too bad. Um, I'll explore it. That's what we're going to probably do. We're just going to explore it, we're going to prototype, and we're going to test it. And if ever I change it in the future, I will make converters so that way you guys won't lose map data. Yeah, we got that. And let me go find our data objects here. So we've already tested the section almost to perfection. The only thing it needs to be tested with is, of course, is saving, which is actually done in this one here. So I'm going to have to do some save tests inside the chunk to make sure the chunk actually saves and loads. And then there's, of course, some saving that has to be done in here, which we've already covered. But the only thing we're going to work on is getting this to run, which means we want to focus on this class primarily, because this one is tested and this one functions. So there's nothing really to work on in here because all of the real bulk of the work is up here. And of course, we haven't quite tested this and done anything with this. Yeah, there's some save all checks that have to be done. Equality should work just fine. Yeah, of course, we don't have any to save all load stuff. So let's do the first thing, which is we need to take our set methods and our get methods. So what I'm just going to do is I'm just going to copy this whole bulk here, and we're going to do this. We're going to empty these out because we just wanted the frames of the methods. We didn't actually want the contents because we actually do have to add things to this. We have to add world. Put these in here. And then what we want to do is we want to return -1 by default. That'll be our indicator for null right now because we're using extended block metadata, which even though we can have a negative value, we're not going to use the negative value. Actually, no, we'll put 0. Maybe. Yeah, that'll work. We want to do extended block data map equals get map world, and then we want to create it. So if it's not there, go ahead and create. And we want to go, okay, if map doesn't equal null, we're still going to put a null check here for stupidity reasons mainly. Then we're going to return map.getValue, and then just be XYZ. Not a lot of work you had to do right there. So that's straightforward. We want to do the same thing down here, except instead of returning get, we want to return set value x, y, z, and then value. And then we'll just copy and paste this right down here. So that gives us all of our set and get values. And that's pretty much the only thing we really needed to do here. The next thing is we need to create this instance here. So we want to go public static final extended block data manager. Then we're going to go instance equals new. There we go. And we want to set this to private so you can't recreate this. Actually, we'll do protected so that way if I ever want to extend this for something else, we can actually do it. If I didn't fat finger the keys there. Horribly fat fingered the keys. So that's good. That gives us our instance. We're going to want to register our instance at some level, I think. Actually, I think just by the fact it gets created, it's actually going to register itself. Yeah, this looks fine. Reality of it, by the way, is we actually do want to throw this up into the Volts APIs where this actually really needs to go. So that way, if you're interacting with my mods, you can go, okay, voltsengine.api.extended block storage, and all of a sudden you have complete access to the extended block storage. But we don't have any API interface here, so we have nothing that you can get access to this right now. And I don't want to expose an internal class to an API, because if you want to have that API included in some way, then that would prevent you from compiling if I did it that way. That'll be something we'll work on later. Right now, this should function, and we could go ahead and start using it. So let's go find our heat block, and let's start toying around with some textures with it. Had to do a lot of toying around, actually. So it's in the core is where this is at. And on top of this, we actually do want to go to the actual core engine class is where it's actually registered at, because we're going to have to toy around with this. So notice how we got a conversion of stone to heated stone, and there's a metadata value in here. We need to make a version of the placement data that then has a change in how this metadata works. Right now, the heated stone is designed to use metadata for temperature. We want to get rid of that. We're not going to get rid of that right now. We're going to get rid of it later when we finish the heat map. So when we get the heat map done, which is going to happen after the extended map, then we'll get rid of it and then we'll start working with the heat map. Right now, the heat map, I am thinking about just flat out using a float for it, because with a float I can get really large numbers, although my precision is going to have problems. There is a limit on precision. That's the biggest issue, is that I know I'm going to need numbers in the millions, potentially billions, in order to do things. That's tempting me to use a long right now, because a long would give me 64 bits of precision and would allow me to have a really, really ridiculously large number. But at the same time, then I'm using 64 bits of data per block, which then the heat map is actually going to have a lot of information stored in it. So the potential catastrophic end of it is if you're talking 64 bits times average world height, which is actually 128 because you rarely get bigger objects than that, times 16 is a single chunk. So right now we're using 2 megabits per chunk. Divide that by 8, of course, to get down to the thing. So let's say 262 kilobytes. And then you want to times this by 25, and then times 25, which is, I think, the max view distance. So we're at 163, almost 164 megabytes of additional memory just for heat data if we use a long. That's actually problematic because that's per player. That's maximum per player, might note this. The heat data is very likely to maximum on you real easily because heat will spread out over a distance. Now, when it does get to the average, so when it gets to the average world temperature, which is about it's going to be 70 Fahrenheit more than likely, then it's just going to delete that value and ignore it. So there is a handler I will implement for it to kind of fix the memory problem, but it is very likely that there will always be one there if I use large data values. That's where I am in trying to figure out some balancing point between it, so that way we can store large values without having problems. Potentially one of these is to use multiple values, not just one. So instead of using one large value, we can use a small value, and then we can use a big value. And the big value could be an integer, and you could be storing that in millions. And then your small value could also be an integer where you're counting up to 1 million and then you're ticking over. So that way well, I guess 2 ints would be the same as a long anyways, but there are ways to figure this out, and I'll talk about this more so we're not spending too much time on this. Right now we want to go ahead and implement this in the heated stone system. So trying to think of the best way to do this. Right now get icon is where I kind of want to do it. So we want to go int icon is what we're going to call this. And we want to go extended block data manager dot get, or instance, then dot get value. Shoot, we can't do it here. We'll have to, there's an actual separate method for this. Get icon, and it is unfortunately a block accessor. Can I get the dimension ID out of this? I think what I can do is check to see if that's an instance of world, and then we can try to use it from there. I never did like the fact that they have a separate interface for iBlock access and they don't really use it anywhere else, because it is kind of really limiting on the method call. Anyways, we're going to change that to world. Actually, what we're going to do is we're just going to go and remove this. And then this is pretty much X, Y, Z, and then side. And I accidentally deleted a comma. And then if we can't find what we're looking for, we're going to switch it to block stone by default. And this is going to be block stone 0 because stone doesn't have a metadata value. And then we're going to go, okay, if world is instance of world, which is counterintuitive when you think about it. We were checking if something is the name of which it is, but oh well. We then want to, of course, get our metadata value here. And this is going to, of course, be world X, Y, Z. Cast of that. And we're going to go, okay, if icon doesn't equal 0, because 0 is, of course, error, is what we're actually doing here, is we're going to grab the block. So we're going to go block equals block dot get block by ID icon. And then we're going to return block dot get icon. and then we're going to get the metadata in the side, or side in metadata. So it's side, and then metadata would be 0. We could easily expand this so we can get metadata values. We may look at this later. Right now, we have 32,000 different values, and we're going to be using the first, which is, or better yet, we'll just do it this way. So 32, so we have, I'm trying to think of like how many values we have. So it's one, I think it's 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So we have 2 bytes worth of information, which is 16 bits, is what we have to store with it as a short, because what we're actually getting back is a short, which if we actually do this, that'll actually be what we get. We're going to be using these back ones for the block ID, and then we're going to use these front ones for the metadata. I'm not going to do metadata at the moment because most of the blocks we're going to be turning into don't have metadata as it is currently, so there's no point in bothering to be converting metadata back and forth. But I need to figure out really quickly how many of these I need to store 4096. We can do that via a calculator. So we got dec 40996. That's not right. Because that's... We're missing something here. It's probably my brain not going through the steps correctly. Because that's saying in order to get 4,000... Actually, you know what? This value can be 4095. There we go. That's what I was thinking. Closer to. So that means we are using these ones for the block ID. So if we go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. So those are our block ID. That means we get 4 bits for metadata, which is surprisingly, I think, what we have currently for metadata. Because metadata goes all the way up to 16. In order to get 16, you need 4 bits. So this is going to be our metadata. 1, 2, 3, 4. That's actually surprisingly not bad. So if I do 16 in here, oh wait, I'm in the binary converter. I need, okay, there we go. Okay, 16, there we go. So of course it's going to put a 1 value here because that's where 16 actually is inside the data table, but the reality of it is 0 counts as a place. So what you're actually doing is you can go up to 15, which is going to be your 4 bits, so that's going to be your 4 frontal bits. Now we could put these in the back, although I got to do the bit shifting, and I think if I just shift left by 4, it'll work. I'm trying to think of the best way to do this. I'm going to have to like do a lot more studying of bit shifting and stuff because it's really powerful. I've told people it's really powerful in the past, but the sad thing is I barely understand how to use it. But this is what we're going to end up doing. So we're going to end up using the back 3 as our block number, and we're going to use this. And oddly enough, I think this is exactly how Forge saves it too. It uses 3 bytes, I believe, or uses. You got your normal block ID, which I believe is that one, and then Forge has got an extended one, which is another byte or another section, and then it does the metadata or something like that. I think it actually uses 2 shorts or something. Details. That's all I can tell you. That'll work though. So that'll get us our icon right off the back. Then we just have to work on a placement data system. I'm trying to think of the best way to handle this. Because what we're going to need to do is we're going to need to fake out what we are. So we're going to need to at all times understand what kind of block we are, so that way when we're done heating, we can go all the way back to the block we need to be. So if we need to turn back into an OR block from IC2, it will let us turn back into an OR block from IC2. That's going to need a lot of handling. And I think I'm just going to prototype this really quickly because of the fact that there's some nuances I think I need to mess with. Okay, so this is a, oh wow. all placement data extending a block pair? Okay, so I may have misdesigned the heat system, is a good way to say this. Because right now all of our placement results are dependent on quite a few things here. Okay, they're dependent on placement conversion data, which uses placement data to work. So it goes original block to resulting block, which uses placement data. So we have a lot of work cut out for us. I'm trying to think of the best way to handle this. Because we need to change this. So this is one of the biggest things we actually do need to change is implementing an interface for this. So we can convert from one block to the other procedurally, where we don't necessarily have to store the value in there. So we can go, okay, anything that's made out of this material can get converted. Which right now we don't have a conversion system that's specifically designed for materials. That's something we're going to need. Man, I need to redesign this whole thing. We're going to need an interface for placement data because we want some way to identify a block, and then we want some way to identify the result, and then we need some kind of way to convert things properly. So I can say my result turns into stone, but the reality of it is when you go to run the placement, it might end up as something else. We're going to do a temp fix right now, and then I'm going to come back through here and I'm going to do a better fix. Right now, what we're going to do is we're going to piggyback the placement system here. Because right now the placement system is going to guaranteedly run through this. So what we can do is make a protected method, public void do place. And what this will simply do is run that method right there. So we're going to need these right here. The irony of looking through this, it looks like I actually coded this up really, really well. I mean, look, it's nicely documented. I've actually got final modifiers and everything. This is something I don't keep up with on almost anything I work on, even though that's actually a de facto standard that you're supposed to be doing with Java programming. So we want to do a do place here, and that way we're going to just change this to a do place. That gives us access to that exact piece of code, which is we can then just only override this piece right here. Of course, we need the world. And that's by default when it runs, it'll check to make sure the chunk is loaded. It'll make sure that our chunk, yeah, this, I don't think this code actually works right there. It'll ensure that we're not trying to place the same block over again, so it's not going to give us the same data result. It will then do a anti-simulation thing, so we can do simulated checks. I don't know if anything actually simulates on this. It'll then place in, it'll of course get us all of our results, because there's a lot of little block edit results that run here, which are used for the threads, is what they're mainly used for. Anyways, let's go ahead and do this real quick. Handles the actual block placement. Override this to modify placement and add additional data. So what we can actually also do with this is say we want to place a chest in the world, we actually could have done that. The placement data, surprisingly, more than likely was never originally designed for the heat system. This is the reason why it looks this way, and probably why it was implemented the way it was. It's more than likely I designed it for the blast code, and then I never ended up using it. Let's do this. Actually, I didn't need the simulate part. Returns true if placed. Cool. So we'll override that and make our own little placement thing. And we're going to... Where is this even located at? It's in world edits. Yeah, if it's in the edit package, it definitely was not originally designed for the heat system. So this would be library, world, edits, and there's placement data right there. So what we're going to do is we're going to create a second version of placement. So we're going to get placement, what do we want to call this? So we got placement data. We want to need to match to the name. So it's got to be placement data, and then we're going to maybe just call it extended. We didn't want to actually copy everything. Shoot. Let's do this real quick. Yeah, that'll work. And then we can extend placement data. And I can get rid of this up here because that's not what we have. Create constructor matching super, and then what we want to do is go short extra data equals 0, and then we do this short extra data, and we don't want to do that. We want to go extra data equals extra data. This would be public final, and we want to remove the 0 off that. We'll make a second version of this real quick that calls the current version. We just want to go this block meta and then extra data, but we want to change this to an integer. That way we don't have to autocast ourselves. It'll just save us a little bit of time. Go. And with this, how we want to do is we want to go, okay, if we actually set the block, we want to make sure we return false if we don't. We want to return true if we do. We then want to go extra, or what was it called? Extended block data manager dot instance dot set value world x y z, and then extra data. And then we need to borrow some code from a few different places here. Well, not really code, but I want this piece up here. So I got to make sure that that little copyright thing is at the top of almost everything, or somebody will get the idea that the class isn't copyrighted. Modified version of placement. And this was made on the 23rd. Cool. And this should work. So what we want to do with this is we want to come over to, well, not this stuff. We're going to leave this open because we're probably going to use this again. But we want to open up the core, go to the engine, and we want to modify this. So this is going to be new placement data extended. And then right behind here, we want to go block.get ID from block.stone. Or blocks.stone, because I forgot they don't store stone in the block class anymore. And we want to do the same thing with cobblestone. Really funky to see cobblestone all colored. And we're not going to do any of the weird types. We're not going to do like stone walls right now. That's something we're going to have to handle later because we're going to need a special render handler for it. But that looks good. So that gives us 2 blocks to toy with and test our system. Then the last thing we want to do is down in here is this spot. We want to change this. So we want to, you know what, we're actually going to change this to block ID. Block ID. And cool, let's roll down there so I don't have to change anything. So we're going to turn to stone. If every time we get a 0, we're going to turn it into stone rather than doing anything that way. And then with this one, what we want to do is we're going to go, okay, if block doesn't equal null, which we actually need to do up there to prevent the game from ever crashing. It's okay to have the world corrupt slightly. It's bad to have the game crash and then corrupt severely, because crashing can result in corruption if you're not careful. So what you want to do, especially if it's a render base, there's no loss of data. So if you have a render fail, it's best to go to a backup render. But somewhere down here, if this fails, worst case scenario, you place a block of stone. Yeah, let's make sure we actually have an else statement here. So if we ever get a bad ID, we just turn into stone. And worst case scenario, you lost an expensive block and it turned into stone. That's the worst case possible situation. So what else we got down here that probably needs to be modified? Everything looks good. And we're almost done, so hopefully we can test with this and I can call it a day here because I actually have a few other things I need to go get done. Words are a little complicated here. So I still got to clean my house. I've been cleaning most of this morning, trying to kill the fleas off my house. My dog managed to pick up some fleas here like a couple months ago from outside, and we keep continuously trying to get him killed off, and now I spent the whole day vacuuming and shampooing the carpets and vacuuming every surface that I could think of, bleaching things to kill any flea eggs, scrubbing everything. Bit of exhausting. I still got to get back to it here, and I got to pop in and say hello to some people and pick a couple people's brains on block maps and trying to see if what I'm doing is going to end up with a good result. Because last thing I want to do is end up actually making a lot of these heated maps and stuff, getting them implemented, being fully reliant on them existing, and then making your guys' games run really bad. The goal is to always make sure that our mod packs run on potato computers. So Volts, for example, has been a mod pack that's always run well on small, low-end computers. You should be able to go pick up Toshiba Netbook, which is what I used to use in school, which had 2 gigabytes of RAM and be able to run the mod pack with 10 to 20 frames per second. The goal is that an average computer which has about 4 to 8 gigabytes of RAM should be able to run at 60 frames per second. Or at least 30. 30 is not too bad. Anything above 24 is good because then your brain processes motion properly. Anything lower than that and the game feels bad. Let's go ahead and test this. Okay, so we want to move somewhere where we're not next to this because that's already running its little code section here. Let's turn day on. Time, set, day, game rule, do daylight cycle, false. Oh, let's nuke the water. I shot myself with a nuke. That was that shrapnel you saw fall. I shot myself in the face with it. Let's try that spot. Nice big mountain here. We can carve out some water so we can test the water code while we're testing this. I need to work on the shrapnel. Speaking of which, I want to look away here real quick so I don't get blinded when this thing goes off. Is it done? Watch me still get blinded. Yeah, it's still removing code. Ah, I still got blinded. I need to work on that code. That's got some serious problems. There we go. Okay. So this ran. Either the thermal code hasn't run or it's having difficulties. Let's go ahead and pull the console up. I'm not seeing any problems with it, so it might just be having some difficulties here. It did look like it had some problems removing water, so that's an issue that I still got to work on. But I want to see this thermal code run. Oh, we had some problems here. Oh, it's trying to load the save map from the disk and it can't find it. Objects do not have save. Okay, yeah, it's gonna spit that error and check for a couple minutes here. We'll have to fix that in a second. That's a real easy fix to do. Actually, you know what? I can fix that like right now. Where is? Yeah, we'll click this, and then right here in the constructor, we're gonna go save manager dot register class, and we want to go extended block data map. And then we want to go extended block data map.class. So the class is the one that has a save ID attached to it. And that should be fine. And then we'll register the other ones with a different method here later. I'm still not seeing the heat map go off. It may have failed to run properly. Okay, so let's go look at the engine and see how I registered these. Still heated stone. Everything looks fine. Let's go ahead and run a marker here. And we're going to restart the game because I'm not seeing anything working here, and I can't tell what's going on. And of course, we're still having problems with a few different things. Wow, it's yeah, we need to fix the save ID problem. So I'm gonna go ahead and kill this because it's just gonna infinitely just screw up here for the next few seconds. So we failed to register the save ID for the map. Now we gotta register the save ID for the chunk. Because if we don't do that, it'll error out on the chunk as well. How we do the chunk, by the way, is we just somewhere in the top here we make a static, and we go like that. So that way, as soon as it's done loading, it will actually do it. We just want to name this exactly what it is. So chunk data short, and then chunk data short. That way it'll register with appropriate IDs when it goes to save manager. I do need to just recode the save manager because the IDs are not important. A lot of the stuff we do save is never loaded via ID. The only reason it was insisted upon is back when I was working on like Artilex version like 8 or something. Everything was loaded via save ID. So you would go, okay, it does contain save ID, and that's how you confirm that your data was valid. To be honest, I probably should do it more as well to prevent people from dumping bad objects into the folders. But the ideal currently is that you're not going to throw garbage objects into your folders. If you are, you're breaking your own saves. There will be handling for quite a few different things, but not particularly that. So that'll work, and then this doesn't need a save object on it. This kind of does. Actually, we don't even have a virtual on here, so actually we don't need to save this one because this isn't saved. Let's get rid of that. This will have iSave attached to it. Implement methods. But we're going to save this via the world. So the world's going to handle all the saving for the chunk data. And that should work. And what we'll do is we'll throw iSave on here as well here while we're at it. And I'll come back and I'll implement these two later. Because this will let us do a lot of really cool things if we implement this correctly. And make sure I actually return MBT here. We will have to save the block data in a super method, but you want to go ahead and put that on your base objects. That way all your base code will run. How this will work is you'll save your chunk sections here. So you'll basically go to do loop chunks. Actually, we got time for this. Let me just do this real quick. So how you're going to save this, you go MBT tag list equals new MBT tag list. And you're going to go for int I equals 0. I is less than sections dot length I plus plus. And then you go mbt dot set tag, and this would be sections, and this would just be list. And you would go if section dot I doesn't equal null, then you would save it. And of course you would go to do does need saved. So you would run some kind of validation check right before you would save that just to make sure you need to save that. But then you would make a new MBT tag compound here. Tag equals new MBT tag compound. Then you're going to call section dot I dot save. Why is it not? Why can't I call save on that? Oh, because we put save up here. I felt stupid. We need to go to the section and then put this here. So implements iSave. And then we want to implement methods here. Make sure we return this. So the way we would save this, by the way, is we would save this as more than likely a byte array, and then we'll turn it back into shorts or something. I'll figure it out later. There's a way to do it. So then we go save MBT, and then you want to go list.append tag. And you're saved there. And also we want to go tag.set byte, I think. Yeah, that'll be byte. And we want to go y because you're storing y level. And this would be I. There we go. So you would store your level in here, and actually if we put this after the save, we prevent the save from corrupting that Y level so it's always the same, and if they stored something with the letter Y in there, that's their own fault. Actually, we can make this better by going section ID. A little bit longer on the save here, but that's how you would save that, and when you load it, you just do it in reverse order, and that's how you load your entire chunk data. That's not how Minecraft does it, of course. Minecraft, I believe, actually stores it as a big array of bytes, and then they read it back out. That's more efficient. We may move to a system like that. Right now, I'm just going to do what I'm doing right now, and that should be fine. There we go. Let me kill a couple of my other windows off here. I was actually planning on streaming today, and I never got around to it. But yeah. Eventually we're going to get to a point where we're going to be streaming all these videos. So as I'm making these videos, what I'll do is I'll throw a stream up and you guys can watch in real time as I make them. There's very rarely ever editing with these, so you're not going to miss anything if you just watch via YouTube. That may change though down the road. I may start adding like diagrams and pre-clips and etc. Probably never get to a point where I'll do voiceovers. And I mean, we look like we're doing okay here. There's a lot of things we do need to sort of do. Like, I gotta do all the save stuff. You know why we're not actually seeing any changes client side? I just realized we're storing all this server side. So this code is probably running perfectly fine, but we can't access it. Let's go into one of these and make sure it's registering correctly. Extra ID is 4. That's cool. Go in here, add conversion. Yeah, we're good. So those registry keys are running just fine. So there's nothing wrong with those. I didn't think there was, but you always got to check just to make sure. So what's going on is we don't have this data client side, which is going to be problematic. That just makes a whole new problem by itself, as now we have a bandwidth problem. How to do that? That is a whole problem by itself. I was just talking to Lim about this too, because he synchronizes some of his data client side as well. So yeah, that didn't occur to me at all. So what we're looking at here is that these are probably running exactly as planned, because if I probably come up to here, nope, that's still stone. Okay, so it's not placing maybe. So maybe we still do have a problem, but it's not as big as one as I thought it was. So we're going to go ahead and run this again, and hopefully the thermal code actually runs this time. Okay, I got blinded. Interestingly, you can actually still see when you're blinded because that the alpha on the bubbles kind of screws it up. You see what I mean? If you like sit there and pay attention to the bubbles, you can see through them. Because the bubbles do an inversion, and then the blinding is just a pure black, so an inversion of a pure black is actually transparent. Okay, so we got our alpha here. Okay, so we're getting our data. We're getting cobblestone here too. Oh, you know what? No, that should have worked. Why am I not getting my confusion? That's all cobblestone right there. That's all heated stone. What did we hit right there that was not normal material? I want to say a lot of this is ore blocks right here. That's ore blocks right there. That whole wall shouldn't have turned into cobblestone. Unless it already was cobblestone in the first place. Let me go through this wall here real quick and yeah, that cobblestone does go for a while, so... Did we run another blast nearby here? Yeah, there's one over here. I mean, we're running one right there. Oh, that's right. I shot myself in the foot, like right here, so maybe that's why that turned into. Hard to determine this, as we don't have a good way to indicate it. But this thermal stuff is running. What I'm gonna have to do is quickly change one of my debug tools. I'm gonna go ahead and close all of this. I will have to figure out. Actually, you can't do a close all. There it goes. That was weird why I couldn't close all on that first one there. But if I go into here, I can go find one of our dev tools. Asset crafting, screw selection. There should be one in here called dev tool. Probably. Oh, yeah, it's under debug. Item dev data. Okay, so what I can add to the basic data is I can add the extended block data. So we want to get extended. This would be block. This would be extended block data manager dot instance dot get value world x y z. And let me check the get value here. Actually, we want to do false on get, all the get methods, because we don't want to create worlds by default here. Go ahead and reload that, and this means I should be able to click those and we should be able to see what they are. Okay, so let me get the dev tool. Should be one of these ones. We want the simplified one. Our extended is 0 on this guy, so could it not run? I mean, we are getting to the point where some of this stuff is cooling down now. Okay, I need to make sure that we're actually placing it, so let's take a look at... Let's ignore this because we don't need this guy anymore. At least I don't think we do. You know what, I need to actually change this one here. I need to call set value world x, y, z, cast short, then value. That way we only have one of these running. So this looks good. I mean, this will run, so that'll let us get our debug information. And then let me put a space there so I keep consistent with the ones below it. So I'll close this because we don't need to get back at that data. What we do need to do is we need to go take a look at our placement object we just created, which I gotta go find again. And we need to check to see if the placement object is running appropriately. So it'd be world, map, data. Oh, I can hear my mom yelling at me across the house. This is gonna be fun in the next couple minutes. Hopefully I can finish recording before she comes in here. Okay, I'm in the wrong folder altogether. Okay, world edit, extended, here we go. So we want to make sure that this is running. Why am I not firing the nuke? Oh, it did fire, it's just I'm getting some latency here. I can't tell if the latency is because of could be a few things we need to work on here. I do need to keep improving the blast code because we were having some latency problems from it. But that's, of course, I'm running on a potato for a computer. When I originally bought this computer, I thought it was really, really good. And then the more I've been using it over the last 2 years, the more I'm coming to realize that I kind of got gypped into buying a piece of crap. But, I mean, not too bad when you think this is the first custom-built computer I actually got. I just probably should have followed my gut and stuck with Intel instead of trying to get an AMD because I didn't really understand how AMDs worked. Okay, so we got a bit of stuff over here. We're still winding up with cobblestone turning into cobblestone. Or winding up with stuff turning into cobblestone, which I don't quite get. That's heated stone. Extended is 0. 0 should be air, but we're getting... You know what? We didn't hit this due place at all. No usage found. No usage found. No usage found. Okay, I have a feeling that this code isn't used at all. Let's go find our thermal system, and we're not running our results through this. This is the reason why it's not working. So our thermal blast is sitting down into IC beam here. To be content blast, temperature. These both use the same code pretty much, so we're going to fix both of them. Placement data, data, edit.setBlock. Huh.
Bobby, again.
Hi, my mom's yelling at me for cleaning. Yay. Okay. We're gonna end the video here, because at this point I'm gonna have to redesign several different things to fix this, and we'll have to pick that up in another video or some other time.